Okay, welcome back, and let's just get started. We're left off exactly where we were this last time, so you can see I still have my circuit that changes the intensity of light depending on the shadow or darkness. And for the moment, we're actually going to tear all this apart. Okay, so I'm going to pull that out, pull that out, pull that out. Okay, and now we just have a basic chip sitting here. In fact, I think I'm just going to pull this out for the moment. So we have a chip. Now, we need a circuit or we need some places that we can draw power. We're going to be putting motors on here, for heaven's sakes. And if we pull up a diagram, well, let's go here. No, where's it at? Okay. If we pull up this diagram, which I've been showing you on and off, you can see that VN, voltage in, 3.7 to 5.5 volts, is up here at this uppermost pin. It is, oh, you can't see it. It is this one right here. Okay? Now, let's jump back to that. It's really handy. You should all get used to at least being able to read, the diagrams. Because if I look at the schematic, okay, now this can be very confusing. This is the overall schematic of the teensy. You can see that VN, that pin I just pointed to, is directly connected to the voltage supply provided by the USB port. Okay? So if I plug a USB in, I am going to have a direct path from the USB supplied power to VN. That means that we could use VN to power some low current circuits. I'm going to stress that. You don't want to be driving, your dishwasher from your USB port, obviously, but we can use it for a while here to play with things that do not require a lot of current. If you have a hub, especially a powered USB hub, it would be a good time to think about plugging your teensy board into that. However, I'm plugging it directly into my USB port. Some people may not like it, but I haven't had any problems with it as of yet. So we're going to go ahead and, for a while at least, play with that power. Okay, so we're going to use this pin right here to take off power from the USB cable. Okay, to do that, we simply need to tie in to this row of holes here and tie it in to our positive bus. To do that, we just need a short little wire. And to start you off with that, I'm going to show you a little trick. We want to make a little wire. I have a bunch already cut, so you don't have to sit there and watch me do it. Okay, we need little wires like this, little staple wires. And these can be really kind of annoying to make if you sit there and think, oh, I'm going to hold on to this and strip this end off and hold on to the other end. You can barely hold on to them at all and strip both ends. Well, there is an easy trick for that. You find yourself a piece of wire, and I'm going to do it up here on this camera for the moment, and I'll show you both. Okay, I'm going to strip off. If you have one of these, you're lucky. Way cool. Very easy to use. But I'm assuming you don't, so I'm just going to use my Leatherman, just any old thing that'll cut. I'm actually going to strip off quite a bit of wire. Okay, I'll hold it down here on this camera so you can see. I stripped out essentially twice when I need, because this is going to be both ends in a minute, and I'll show you what I mean. Now I'm going to cut my little staple size length of plastic. So I've made this little thing here, okay, which is mostly stripped, but just a little bit. And then I'm simply going to slide the insulation, and sometimes it helps to have a pair of needle nose to hold on to it. Slide the insulation into the middle, like so, okay, and bend it. Okay, in this case I've made this end, this end, a little long, so I'm going to trim off the excess. Okay, and I just made myself a nice little staple piece of wire. And in fact, I'll just go ahead and use it. And I'm going to insert that little staple piece of wire into that very first row we were talking about. Well, I probably should have glasses, I can tell. I can't see that well. Okay. So now, any power that comes up our USB is going to go directly to this pin and then directly to this bus. Alright, so we've done that. Now let's look at the chip. Okay, you should have a chip like this. Every chip has an orientation on it. It has a little notch. Okay, that notch is going to be the front. This is going to be the very first pin. The one that is to the left side, closest to the notch, is the first pin. This is the L293 motor driver. I'm going to put it really close, actually, because I don't think we're going to stick anything between. You can stick it kind of where you want to, but I do have the notch up here. Don't be fooled by the little dot. There's in fact a notch right there. And let's look at the diagram of that guy. You should again be getting used to reading data sheets. I just pulled up the data sheet, and you can see that the 4 pins in the middle, 2 on either side, are heat sinks and grounds. These guys go straight to the ground bus. So these guys, here, here, and here, go straight to ground. Well, let's just do that. I'm going to do it real quick, hopefully. Maybe I'll have to pause. You know what? I'll do one, and then I'm going to pause it, and you'll see them magically appear. Okay, and give me a moment and you'll see more of them just magically appear. Okay, they all just appeared. What I've done is I've completed this. And actually, you know, we can look at it. There's so many. Let's look at just this. Okay, that's much bigger, easier for you guys to use. So I've hooked these all up to ground. Now, 1 and 2 enable, 4 and 5 enable. These are the pins that tell it to turn on and off each side of the chip. This side of the chip, I'm sorry, up to pin 7, this side of the chip is going to be turned on and off by this. Ultimately, we're going to be using this for regulating the speed of our motors eventually. This side of the chip, 9 through 15, are turned on and off with this. So if we want these, both sides of these turned on, we should set both of these to high. These should be hooked up to this here. So we want both this one and this one going to the positive. And again, I'm going to pause it and you'll see it magically appear. Okay, so you can see now that I have a small jumper, red jumper, going to this bus, hooked to this pin. And I have on this side, I have this wire going to this. So now both of these, when it gets powered up, will be high. They will turn on this side of the chip. Let's go back to our web drawing. Okay. The motor actually hooks up. In fact, we can see other diagrams. Here, let's jump to this one. Oh, it's little, but the motor hooks up to the 2 pins on either side of those ground centers. Let me find a better one. A little bigger. Okay. Oh, I like this diagram. The motor, here is going to ground. Remember that straight line's being ground. Okay. The motor hooks up to either of those pins on just on the other side. So I'm going to do that right now. Here's my motor. Okay, you should have one like this. And I'm just going to arbitrarily choose to stick it here and to here. We'll just do one side. We're going to do the left side first. Okay? So now my motor, it's hard for you to see it all, but it's all there. Okay? My motor is now connected. Last thing. A and B. Okay? These are the 2 remaining pins. Let's just look at the left side. There's only 2 pins right now. Well, that's not true. There are 3. A and B, okay, are these 2 pins. If we go back to our diagram here, these are labeled A and B, and they're the ones that control the direction of the motor. If this one's high and this one's low, the motor spins one way. If this one's high and this one's low, the motor spins the other way. Okay? And I'm going to hook these two up to, I'm going to hook them up to the very first 2 pins of our chip. Alright, and again, I'll pause it because I don't want to run out of time. Okay, we're nearly done. So I have done exactly that. I have this pin down here, okay, connected to pin 1, and I have pin 0, it's actually labeled that, pin 0, is connected to, which is hard to see, but it's the second pin from the left on the top. It's kind of underneath our motor wires. Alright, so it's connected to this one. We are nearly ready to hook this thing up. Let's do our last little connection. Okay, we have VCC1 and VCC2. Now, we can run VCC2, this one right here, powers the motors directly. This will be the supply of batteries, for example, that drives the motor. This is going to be the power that drives the logic. This powers the chip. This powers the motors. And there's a huge range on this particular chip. Let me go down here some distance. VCC1 and VCC2 can go all the way up to 36 volts. Okay, if we look at the data sheet. So we can use a large amount of different ranges of electricity, different voltages. So let's hook it up. We're going to hook both VCC1 and VCC2 to our positive bus. They're both going to get the 5-volt supply from the USB, at least for the moment. It'll work fine. Okay, I'm going to pause it. Okay, as I promised. So now I have another little staple wire here. It's hooked up to this very first pin on the right side, the very top pin. That one powers the chip. And I'm also using the same supply here to power the motor. Okay? So hopefully, especially if you start looking at other diagrams, like for example, where was it at? This one. In fact, you can see that's what they did. They tied everything into the same 5-volt supply. Okay? That one's hooked into 5 volts. That one's hooked into 5 volts. That one's hooked into 5 volts. And that one's hooked to 5 volts. That's enable. That's enable. That's chip power. That's motor power. Okay? This is a nice diagram for what we're actually doing right now. So, that being said, I think it's time to write a little bit of code. And I'm going to do it like, well, let's just do it. Okay. See if I can do this real quick. Right off the bat, because we might have to skip some comments here, because we are almost out of time. Oops, I've already, my goodness. Okay. We know we've got it hooked up to pins. When we hook it up to pins, we almost always use a constant integer. Okay, let's call it your left A. Okay, remember there's the right side and there's the left side, and A and B. And we'll make that one equal to pin 0. And I'm going to try to do this really fast. We also have a left B, and it's hooked up to pin 1. Okay? What else do we need? We need our setup, and of course we need our loop. Okay, and the setup, you can probably figure we're going to need to set those pins to output. Oh, I have only 45 seconds. Tell you what, we're going to end this right here, and on the next video we're going to pick up exactly at this point. I will see you very shortly.